14 hours ago, something happened in our solar system that should not be possible, and if the data is correct, then what we are witnessing is not just an anomaly, but a complete breakdown of the rules that govern motion in space. It is March 31st, 2026, and NASA's Deep Space Network recorded an event near Jupiter with a probability of natural occurrence so small it is almost meaningless. 0.00001%. That number alone should stop you, because what followed was not random, not chaotic, and not explainable by any existing model. The interstellar object, known as 3I Atlas, did something no comet, asteroid, or natural body has ever done before. It didn't just pass through the Jovian system. It didn't slingshot around Jupiter. It didn't enter orbit. It physically attached itself to Europa. Take a moment to process that. This object entered our solar system at interstellar speeds, moving faster than anything bound to the sun, and somehow slowed down enough to perform a controlled landing on a moon located 628 million kilometers from Earth. Not a collision, not an impact, a landing. The precision required for that maneuver is almost impossible to describe. We are talking about an alignment error margin of less than 0.03 degrees. That level of control demands deceleration. It demands timing. It demands something we do not expect from a dead piece of rock and ice. When scientists reviewed the telemetry, the situation became even more difficult to explain. NASA repositioned the Juno spacecraft to observe the approach just hours before contact. The data showed something completely unexpected. Instead of accelerating uncontrollably as it entered Jupiter's gravity well, 3I Atlas began to stabilize. It slowed down in a controlled manner. It did not fragment under stress. It did not heat up and break apart. It adjusted. At the same time, the European Space Agency's JUICE mission, still en route, independently confirmed the thermal patterns during descent. Two completely separate systems, using different instruments, recorded the same conclusion. This was not an observational error. The object had reached Europa and was now stationary on its surface, perfectly aligned with long fractures in the moon's ice shell. Now picture what that means. An object from another star system navigated one of the most complex gravitational environments in our solar system and touched down on the one moon scientists believe is most likely to contain life beneath its surface. And it did so without causing an impact explosion, because that is the next critical detail. A natural collision at those speeds would have released energy equivalent to a massive detonation, shattering the ice and throwing debris into space. But that did not happen. Observations showed no impact flash, no ejecta plume, no shockwave. Instead, instruments detected a controlled thermal exchange at the point of contact. This is where the situation shifts from unlikely to completely unexplainable. According to both classical and relativistic physics, objects in space either crash or continue moving. They do not stop themselves with precision. They do not dock. Yet the Deep Space Network confirmed it clearly. 3I Atlas is at rest on Europa's surface. And that alone would have been enough to challenge everything we know. But it was only the beginning, because immediately after making contact, the object started doing something else. Something that triggered emergency responses across multiple space agencies. It did not remain still. It began preparing to go deeper. Let's step back for a second and understand what 3I Atlas actually is. Discovered in late 2025, it was classified as the third known interstellar visitor, following earlier objects that passed through our system without much consequence. At first, it was assumed to be a rogue comet, a frozen remnant drifting between stars. But even then, something about it was unusual. Unlike typical comets, it did not release water vapor in the expected way. Instead, it showed a structured electromagnetic signature. That alone raised questions. But unusual behavior during a flyby is one thing. What it is doing now changes everything. Because at 6:14 UTC this morning, a new wave of data arrived, and this is where the situation moves from impossible motion to something that looks very much like controlled action. Stay with me, because what happened next is where this story truly begins. At 6:14 UTC, the first major data set reached Earth, and it immediately revealed something that should not exist on an object like this. Europa's surface is one of the coldest places in the solar system, averaging around -160 degrees Celsius. Any object landing there should simply freeze into place. But that is not what happened. Instead, 3I Atlas began generating heat. Not random heat, not surface warming, but highly localized directional thermal output. NASA's Juno spacecraft detected the initial temperature increase using its microwave radiometer. At nearly the same time, the European Space Agency's JUICE mission confirmed the same pattern through its own instruments. Even ground-based observations from Hawaii matched the data. 3 independent sources, 3 different methods, 1 identical result. The object was heating the ice directly beneath it, and it was doing so with extreme precision. The heat was not spreading outward into space. It was focused downward, targeting only the contact area. Imagine a tool designed to cut through ice without disturbing the surrounding environment. That is exactly what the data suggests. The temperature reached a precise value of 114.7 Kelvin. That number is important because it is controlled. A natural object does not regulate heat output to such a specific level, especially not a comet, which lacks any known internal energy source capable of producing sustained thermal output like this. But it didn't stop there. As the ice beneath the object melted, something even more unusual occurred. The water above it refroze almost immediately, sealing the object in place. In other words, 3I Atlas anchored itself to Europa's surface, using the environment itself. This is not passive behavior. This is interaction. Then, at 8:33 UTC, the next phase began. Sensors detected a rhythmic vibration traveling through the ice. The frequency was measured at 4.2 Hz, a steady, repeating mechanical pulse. This is where the comparison becomes unavoidable. On Earth, when heavy machinery drills into ice, it produces a specific seismic signature, a consistent pattern created by repeated mechanical motion, and that is exactly what was detected on Europa. From over 600 million kilometers away, instruments recorded what appears to be the seismic footprint of an active drilling process. Think about that carefully. This object did not just land. It did not just heat the surface. It began penetrating the ice. And by 10:15 UTC, another detail made the situation even more difficult to explain. Spectroscopic analysis of the vapor surrounding the object revealed the presence of heavy metals, materials that should not be found in a typical comet. Elements like titanium appeared in the data, not as debris, but as part of an exhaust-like emission. This suggests that something inside the object is processing material. And then came the most critical observation so far. The object was sinking. At a steady rate of 15.4 meters per hour, 3I Atlas began descending into Europa's crust. The ice melted beneath it and refroze above it, gradually enclosing the object as it moved downward. This is not how comets behave. In nearly every recorded case, objects either shatter on impact or bounce away. They do not initiate controlled descent into solid ice. They do not maintain structure while doing so. And yet, this object is doing exactly that, which forces us to ask a question that cannot be ignored anymore. What if 3I Atlas is not a comet at all? Because every action it has taken follows a sequence. Approach, slow down, attach, anchor, melt, descend. Each step builds on the last. Each step requires control. And control implies something far more complex than a random piece of space debris. As it continues its descent, There is one destination that stands out above all others, the vast ocean hidden beneath Europa's frozen surface. And that is where this situation becomes even more serious. Because as the object moved deeper, something changed. The data started showing behavior that cannot be explained by motion or heat alone. It started navigating. And what happens next is where even the most cautious scientists begin to reconsider everything. Stay with me. As 3I Atlas continued its descent into Europa's ice, the situation shifted from something unusual to something that directly challenges the foundations of astrophysics. Up until this point, you could argue that we were observing an unknown but natural process extreme, unlikely, but still within the realm of possibility. That argument no longer holds once we examine what happened next. To understand the scale of this, we need to look closely at Europa's structure. The Moon's ice shell is estimated to be between 15 and 25 kilometers thick. It is not smooth or uniform. It is a chaotic mix of frozen water, salts, and silicate material, constantly stressed and fractured by Jupiter's immense gravitational pull. Any object attempting to move through this layer would face enormous resistance. Pressure builds rapidly. Melted pathways refreeze almost instantly. Movement should stop, but 3I Atlas is not stopping. Instead, it is managing the environment around it with precision. As it melts the ice below, the water above refreezes, sealing the path behind it. Under normal conditions, this would trap the object, locking it inside a high-pressure chamber with no way forward or backward. Yet the data shows that the object is maintaining a perfect balance between heat output and environmental pressure. Think of it like a deep-sea vessel descending into the Mariana Trench, except instead of water, it is pushing through solid ice that behaves like rock under pressure. And somehow, it is not being crushed. It is not losing stability. It is adapting in real time. Observations from infrared instruments detected a constant thermal output of 4.2 gigawatts concentrated at the leading edge of the object. That is an enormous amount of energy, comparable to the output of a large power plant focused into a very small area. And, even more importantly, there is no sign of mass loss, no visible fuel source, no exhaust plume consistent with traditional propulsion or heating systems. This alone is enough to raise serious questions. But then, on March 30th at 12:44 UTC, something happened that removed any remaining doubt that this is not a passive object. It changed direction. Until that moment, 3I Atlas had been descending vertically, moving straight down toward Europa's subsurface ocean. That behavior, while extraordinary, still followed a predictable path. But the latest radar data revealed something entirely different. The object tilted by 14.2 degrees and began moving laterally through the ice. Not drifting, not slipping, steering. This is a critical distinction. A natural object cannot alter its trajectory within a dense medium like Europa's ice without external forces acting upon it. There is no current model that allows for controlled horizontal movement under those conditions. And the reason for this maneuver makes the situation even more striking. Radar scans detected a dense metallic mass directly beneath the object's original path, likely an iron-nickel fragment embedded deep within the ice. If 3I Atlas had continued its descent, it would have collided with this barrier. Instead, it adjusted its course, bypassed the obstacle, and then resumed its downward movement. That implies awareness, or at the very least, the ability to sense and respond to its surroundings with precision. To do that, the object would need some form of internal mapping system, something capable of scanning ahead, identifying obstacles, and calculating alternative paths in real time. In simpler terms, it would need functionality similar to ground-penetrating radar. Pause here and consider what that means. We are now looking at an object that has entered our solar system from interstellar space, slowed itself down, landed on a specific moon, anchored itself, generated controlled heat, initiated a descent, and is now actively navigating through a hostile environment to avoid obstacles. Each of these actions alone is extremely unlikely. Together, they form a sequence that no natural model can explain. The probability calculations reflect this. The chance of an interstellar object being captured by Jupiter is already incredibly small. The likelihood of a soft landing on Europa without catastrophic impact is even smaller. Now add autonomous navigation and controlled energy output, and the combined probability becomes effectively zero. At this point, the scientific consensus began to shift. This is no longer being treated as a natural phenomenon. Multiple space agencies reviewed the data independently. Instruments from different missions, using different methods, all confirmed the same behavior. There was no discrepancy, no conflicting interpretation. The conclusion was consistent across the board. This object is not moving randomly. It is following a path, and that path is leading directly toward the subsurface ocean beneath Europa's ice. By 1530 UTC, updated radar data showed that 3I Atlas had reached a depth of nearly 10 kilometers. At this level, the ice begins transitioning from rigid to semi-fluid under pressure. It becomes a dense, slushy layer that behaves differently than the brittle surface above. The pressure here is extreme. Conditions are unstable. Yet the object remains structurally intact, maintaining a steady descent. What stands out most in the latest data is the acoustic profile. As the object continues downward, sound waves generated by its movement are traveling through the ice and reflecting off something deeper below. That reflection is becoming stronger, which means the distance between the object and the subsurface ocean is rapidly decreasing. Right now, as this data is being analyzed, the clock is moving toward a critical moment, because within hours, 3I Atlas is expected to break through the final layer of ice and enter the liquid water beneath. And that is where this situation becomes even more complex. Because just before reaching that boundary, the object did something completely unexpected. It stopped behaving like a machine focused on movement and started behaving like something trying to communicate. Stay with me, because what happens next changes everything. As 3I Atlas approached the final boundary between Europa's ice shell and the vast ocean beneath, the nature of the event shifted once again. Up to this point, every action, landing, anchoring, heating, drilling, and navigating, could be described as a sequence of controlled physical processes. Highly unlikely, but still physical. But what happened next moved beyond motion and energy. It began transmitting. As the object closed in on the subsurface ocean, instruments detected a structured signal being directed downward into the ice. This was not random noise, not interference, and not a byproduct of mechanical activity. It was deliberate, narrow band, and mathematically organized. The frequency was measured at 1.42 GHz, the hydrogen line. This is not just another part of the spectrum. It is one of the most important frequencies in astrophysics, often considered a universal reference point because hydrogen is the most abundant element in the universe. For decades, scientists have speculated that if any intelligent system were to send a recognizable signal across space, this is the frequency it would likely use. And now, an object buried deep inside Europa's ice is using it. The signal itself was not static. It followed a repeating mathematical structure, a sequence that remained consistent in timing and pattern. That alone separates it from natural emissions. Random processes do not produce clean, repeating mathematical signals. So now we are faced with a new layer of this event. 3I Atlas is not only moving with precision, it is transmitting with structure, and it is transmitting into the ocean below. Pause and consider what that implies. Every step up to this moment appears to have been part of a larger objective. The landing was controlled, the descent was deliberate, the navigation was adaptive, and now, just before reaching the ocean, the object initiates a signal directed at whatever lies beneath. This suggests that the destination was never just the ocean itself. It suggests there is something in that ocean worth contacting. But the situation becomes even more difficult to explain when we look at what happened next. Because the signal did not simply disappear into the water, it came back. Shortly after the transmission began, instruments detected a returning wave traveling back through the ice. At first glance, it might seem like a simple reflection, something you would expect when sound or electromagnetic waves encounter a boundary. But this was not a normal reflection. The returning signal was altered. Specifically, it was phase-shifted by exactly 180 degrees. To understand why that matters, think of it like this. In signal processing, a 180-degree phase shift means the returning wave is an exact inverse of the original. This is the principle behind noise cancellation systems, where one signal is used to completely cancel out another, and that is exactly what was observed. The signal sent by 3I Atlas was effectively neutralized by the returning wave, but this is where the problem arises. A natural reflection does not invert a signal with perfect precision. It may weaken, scatter, or distort, but it does not process and return a mathematically exact inversion. For that to happen, something must receive the original signal, analyze it, and generate a response. In other words, something must be there. Now, consider the implications carefully. If this is a natural acoustic effect within Europa's ocean, then our understanding of fluid dynamics and wave propagation is fundamentally flawed. There is no known mechanism that can produce this kind of perfect phase inversion under those conditions. If it is an error in the instruments, then multiple independent systems from different agencies using different technologies are all producing the same incorrect result at the same time. But if neither of those explanations holds, then we are left with a third possibility. The signal was answered, and not randomly, not approximately, but with exact mathematical precision. That possibility is what changed the response at the highest levels of the scientific community. Within minutes of confirming the phase-shifted return signal, a series of actions were taken that are almost unheard of during an active observation event. Data streams were restricted, public access to live telemetry was cut, communication from official channels slowed to near silence. This kind of response is not routine. It suggests that the implications of the data were immediately understood, because if 3I Atlas did not come here by chance, if it navigated, descended, and transmitted with purpose, then the return signal introduces a second variable. Something else is involved. And that brings us to the most important question of all. What exactly is waiting in the ocean beneath Europa's ice? At this point, we are no longer just observing a single object behaving in unexpected ways. We are observing a potential interaction, one that began 628 million kilometers from Earth, traveled across interstellar space, and is now unfolding beneath the surface of one of the most mysterious moons in our solar system. And we are only seeing part of it. Because just as this exchange was being recorded, something else happened, something that made it even harder to understand what we are dealing with. The data did not just become restricted. It stopped. And what was captured in the final moments before that blackout may be the most important clue of all. In the moments following the detection of that phase-shifted return signal, the entire situation changed in a way that is almost as significant as the signal itself. Because instead of expanding access to the data, instead of allowing more systems to observe and verify what could be the most important discovery in modern science, something very different happened. The data flow stopped. This was not a gradual reduction or a routine delay. It was immediate. Live telemetry from the Europa Clipper mission, one of the most advanced observation platforms ever deployed to study Jupiter's moons, was cut from public access. In the history of deep space exploration, a full blackout during an active, high-priority event is extremely rare. At the same time, official communications slowed down. Statements became limited. Agencies that normally provide continuous updates shifted to silence. And while no direct explanation was given, the timing was clear. The blackout happened within minutes of confirming that the signal from 3I Atlas had been answered. Now, let's focus on what we do know before that cutoff occurred, because those final pieces of data are critical. By that stage, 3I Atlas had reached a depth of approximately 10 kilometers beneath Europa's surface. This region marks a transition zone where the ice becomes less rigid and more fluid under pressure. It is unstable, dense, and extremely difficult to navigate, yet the object remains structurally intact, continuing its descent at a steady rate. The thermal output remained consistent at around 4.2 gigawatts, focused entirely at the leading edge. There was still no evidence of material loss, no signs of degradation, and no fluctuation in energy levels. In other words, whatever system is generating that heat is stable and sustained. The acoustic data also became more pronounced. As the object moved deeper, the signals it produced began reflecting more strongly from below. That tells us something important. The distance to the liquid ocean was shrinking rapidly. But the most important detail is what happened after the signal exchange. Because the return signal was not just a one-time event, it continued. The phase-shifted response began to change over time. It was no longer a simple inversion. It started to vary slightly in timing and structure, suggesting that whatever was generating it was not just reacting, but adjusting. That introduces a level of complexity that cannot be ignored. A static system might reflect or invert a signal once, but a system that changes its response over time is doing something else entirely. It is processing input and modifying output. In simpler terms, it is interacting. And this is where the implications extend far beyond Europa itself. Because now we are no longer looking at a single anomaly. We are looking at two components, the descending object and the source of the return signal. Two separate points, two separate actions, one exchange. That raises a critical possibility. This may not be a discovery of something new arriving in our solar system. It may be the confirmation that something was already here. And if that is the case, then the entire sequence from interstellar entry to controlled landing to directed descent takes on a different meaning. It stops looking like exploration. It starts looking like a rendezvous. Now, let's be very clear. There are still alternative explanations, and they must be considered carefully. One possibility is that the return signal is a highly unusual acoustic phenomenon, an interaction between sound waves and the unique structure of Europa's subsurface layers. If that is true, then our current models of wave behavior in extreme environments are incomplete. Another possibility is that the instruments are misinterpreting the data, producing a consistent but incorrect result. However, this becomes less likely when multiple independent systems report the same pattern. And then there is the third possibility, that the return signal is intentional, that something beneath Europa's ocean detected the incoming transmission, analyzed its structure, and generated a precise response. If that is true, then we are no longer observing a passive environment. We are observing a system capable of recognition and response. And that changes everything. Because it means that whatever lies beneath the ice is not just present, it is active. As the data stream was cut, one final set of readings was transmitted before the blackout became complete. These readings are now the focus of intense analysis behind closed doors, because they may contain the clearest indication yet of what is about to happen next. And what they suggest is that 3I Atlas is no longer just approaching the ocean. It is to enter it,